Hello and welcome to today's lesson. Today, scholars will apply multiple transformations to create congruent images. So first, let's have a quick review about our rigid transformations. You'll remember from previous discussions that the rigid transformations always create congruent images. The rigid transformations, again, are reflection over a line of reflection, rotation about some sort of rotation point, and then translation, which is just sliding it. Each of these create congruent images. Remember, congruent is just our geometry term for exactly the same. So let's look at this figure over here. We're going to talk about how can I use multiple transformations. Multiple means I'm using more than one transformation. How can I move this image to that image? So as you see, our original image is the black image. I can tell because the red image, it has that wonderful little prime symbol right there next to each of the letters. So if I look at this, I can see that it looks like someone took it and they reflected it, they flipped it, they reflected it. So they reflected it, and then it looks like after they reflected it, they slid it. They translated it. So I can see that they reflected it and then they translated it. So let's talk about what we could do. Let's look at each step. If I reflect over my y-axis, then my figure is going to end up right here. So this would be my, that would be C, A, and B. Okay, so I did that, but now I need to slide it. So it looks like I need to slide it over 1, 2. So I need to go 2 to the right, or 2 to the left, which means I'm going to do x minus 2. And then I need to move down 1, 2, 3, 4, 5. Which is y minus 5. And look, I just turned triangle ABC into triangle A prime, B prime, C prime. Not too hard. Okay, so now let's talk about the corresponding parts. So the corresponding parts of our triangles. So we've seen usually we have something like triangle ABC becomes, triangle ABC becomes triangle A prime, B prime, C prime. In that case, we know A and A prime are corresponding, B and B prime, and so forth. But let's look down here at these triangles. They've told us that triangle ABC is congruent. That's what that little symbol means. That equal sign with that little squiggle over it means congruent. It's congruent to triangle DEF. So now we have to figure out which parts are congruent. Well, we can actually use what it tells us here to know that A is going to be congruent to D, B is going to be congruent with E, and C is going to be congruent with F, because they have to put them in the same order. So we do know that, and if you look here at the triangles, if you look at angle A and angle D, you'll notice they each have the 1 hash mark. That means that they are congruent. If we look at angle B and angle E, they have the 2 hash marks. That means those two are both congruent. And if we look at angle C and angle F, they each have 3 hash marks. The other thing I can see is that line segment AC and line segment DF are congruent. They both have the 3 hash marks in them. I can see the same thing with line segment AB and line segment DE. Again, they each have 2 hash marks. And if I look at line segment BC and line segment EF, I see they each have 1 hash mark. So I can tell which ones are the same by the order they're written in, and I can look and see that the sides and angles are the same. So now let's talk about which parts are corresponding. In this case, I did not give you the names of the triangles and tell you that they are corresponding, so we need to look at it. So I'll notice here that angle A is marked as being 35 degrees. Well, over here, the angle is marked as being 35 degrees is angle E. So that means A must be congruent. Wow, that was not a pretty little squiggle there. Congruent. Angle A must be congruent to angle E. I can also see that line segment AB is 3.8, line segment EF is 3.8. That tells me, so I have AB is congruent to EF. So as you can see, I can see the different parts that are congruent to each other. And I can also see that DE is congruent to AC. So again, line segment AC is congruent to line segment ED. So that helps me figure out which parts are congruent to each other. So let's talk about how can I transform. If this is in a coordinate plane, let's think about how I go from triangle ABC to triangle DEF. It looks like it was reflected because I see that it sort of flipped. So it was reflected and then rotated. Okay, so now you're going to do some practice. If you have any questions, see me in class.